Hello, we are studying the mechanics BSc second year semester 4th. Now the typical topic rate of change of unit vector moving in a plane. In semester 4 there is the first chapter kinematics and dynamics of particle in two dimensions. We know that two dimensions, three dimensions, our classroom is three dimensions. Now in this chapter we can discuss about the difficult article, that is rate of change of unit vector moving in a plane. Now see the diagram, and when seeing this diagram we can construct some information concerned with this diagram. Now we can describe this diagram in such a way that let us consider the unit circle whose center is at origin. Every circle has center is at origin. P is any point on the circle. We can see that P is any point on the circle. Here OP makes an angle theta. OP makes an angle theta. Then this angle theta with OX. Then we can describe this angle as POX or XOP, and whose value is equal to theta. So that OP is a unit vector such that OP is equal to cos theta I plus sin theta j. OP is equal to cos theta I plus sin theta j. Then we can take the derivative of this and then we can take the derivative in both sides, left side as well as the right side. In left side we can see that OP, so we can write d by d theta OP bar means it is vector quantity means it have magnitude as well as direction, is equal to, then what is the derivative of cos theta? Minus sin theta. So we can write minus sin theta I, and derivative of sin theta is equal to cos theta, which can be written as cos theta j. But cos 90 plus theta is equal to minus sin theta, and sin 90 plus theta is equal to cos theta. So in place of minus sin theta we can write cos pi by 2 plus theta into I, plus in place of cos theta we can write sin pi by 2 plus theta into j, which means that, or which is equal to unit vector at an angle whose, what is the value of angle? Pi by 2 plus theta with OX is equal to OQ, which can be shown in figure. If OP is equal to E and OQ is equal to E and OQ is equal to E raised to minus 1 is equal to unit vector perpendicular to E, then dE by d theta is equal to E raised to minus 1. That is, the rate of change of unit vector with respect to theta is unit vector perpendicular to it. Hence d by d theta OP is equal to OQ, and d by d theta OQ is equal to minus OP, which is the final explanation. Now we can take the another bit, that is curvature and principal normal, which is similar to in previous bit. Now we can take the next bit, tangent and normal components of acceleration. So we can see this diagram, and we have the acceleration. Rate of change of velocity is called as acceleration. So we can write A is equal to dv by dt. But rate of change of displacement is called as velocity. So we can write in place of v in place of v we can write ds by dt is equal to I, and which can be simplified by d by dt ds by dt. So it can be the formula of u into v, which formula shows that first function constant derivative of second plus second function constant derivative of first. In this case we can take first constant I is constant ds by dt derivative d2s by dt square, plus in ds by dt is constant and derivative of t dt bar by dt, which can be simply right now, which can be equal to d2s by dt square into t plus ds by dt into dt by ds into ds by dt, ds by dt into dt by ds into ds by dt is equal to d2s by dt square t bar plus k into n bar ds by dt whole square, since which can be written since dt by ds is equal to k into n. So in simple way we can write phi is equal to mod of phi bar is equal to ds by dt, then tangential component of acceleration d2 is by dt square and normal component p square plus p. Now we can find out its magnitude, and magnitude of acceleration is given by mod of a bar is equal to under root d2s by dt square plus p square upon p square, and if alpha is angle made by acceleration at constant t with tangent, then tan alpha is equal to p square upon p divided by d2s by dt square, which can be wrote as an by as. Here an is equal to d2s by dt square There are many examples solved in this book. Many examples in simple way. Now we can see some part in chapter 6. We know it is in 12th science, Newton's first law, Newton's second law, Newton's third law. We can just overlook about this law. Newton's laws of motion. First law, every body contains in a state of rest. Every body contains in a state of rest of uniform motion in a line, except in so far as it is compelled by external impulsive force to change that state. म्हणजे एवरी बॉडी इज इन कॉन्स्टंट. थोडक्यात सांगायचं म्हणजे प्रत्येक बॉडी ही कॉन्स्टंट असते, ज्याशिवाय आपण त्याला बाहेरून फोर्स अप्लाय करीत नाहीत. समजा हे पुस्तक आहे, हे कॉन्स्टंट आहे, परंतु आपण जर हे सरकवलं तर ते पुढं जाईल, म्हणजे त्याला सोप्या भाषेत न्यूटन फर्स्ट लॉ. नाव द न्यूटन सेकंड लॉ. द रेट ऑफ चेंज ऑफ मोमेंटम is proportional to the external force and takes place in the direction of line which the force acts. Also law third, action and reactions are equal and opposite, or every action there is equal and opposite reaction. Some important deduction from Newton's law. The first law, also known as principle of inertia, is self-evident, and the first law gives us